Hey, this video is going to cover part B of the problem set, transformations. So this should be somewhat shorter video. There's not a ton to cover. So you have about 25 questions to do. We'll do about half of them together. So you just got to learn this new notation. So this is this like mapping notation. So it looks trickier than it really is. All this says is for any point that you want to map, um, add 3 to the x value and subtract 1 from the y value. So in this case, so there's a bunch of vocabulary here. So the image of the point. So when a point gets mapped, basically you'll have like a pre-image. And then the pre-image maps to the image. So there's not like a vocabulary test, but you got to kind of know what the words mean, or else you'll just be confused about what's going on when in these questions, what they're asking. So anyway, for this question, the 2, 7 would be the pre-image, and it maps to the image. So all that's going to happen here is that 2, 7, if we follow this rule, we're going to add 3 to the x value. So 2 plus 3 makes 5. And then subtract 1 from the y value. So 7 minus 1 makes 6. And so the answer to this question is the point 5, 6. Now, if you want, you can start thinking about what does that mean visually? Well, imagine that a point on a graph was at 2, 7, and we actually did this to it. What would happen if you add 3 to the x value? Well, adding 3 to the x value would actually shift it to the right 3 units. So there's our plus 3. And then if you subtract 1 from the y value, that actually shifts it down. So as you do these, you can think about, now some are easier than others to visualize. This one's actually pretty simple because you got a point and you go, you add 3 to the x, you subtract 1 from the y, and there you go. It's you've shifted it right 3 and down 1. So anyway, just something to keep in the back of your mind as we do these. So what does this one say? This one says, this is a little bit more complicated. It says that your y value is going to now be the x value. So there's a swapping there, and it also turns negative. So when we do this to 3, 5, the first thing we're doing is we're taking our y value 5 and moving it into the x position, but also making it opposite. So this first number would be negative 5. And then what does it say here? It says that now the y value is going to be 4 times the original x value. So I'd multiply this 3 by 4 to get 12. Okay, this one was a little bit more challenging because you have to swap the values and also change them. So just to reiterate, this one we swapped the x and the y. So there was a swapping that occurred. Also, we made that original y value opposite, so that 5 became opposite. And then the original x value, 3, got multiplied by 4 and became the new y value. Okay. 32 is find the image of this point under this transformation. Well, same thing. Notice there's a swapping. So negative 5, 12. So they swap, and we also take 2/3 of the y value. Okay, so what's 2/3 of our y value? 8. Maybe do that in the margin if you're not sure, but 2/3 times 12. Right, the 3 goes into the 12 4 times, so 2 times 4 makes 8. That's where we get the 8 from. And then we take the opposite of the x value to be our second term. So the opposite of negative 5 would be positive 5. So that's the answer to that one. Okay. You can do 33 on your own. You can apply the same logic. 34, 35, and 36 are going to be a little bit different. This one we're saying if the image of some point P after this transformation is this, what were the original coordinates of P? So what that's asking is, this time we're being told the image, and we want to work backwards and figure out what the pre-image was. So we ask the question, we started with some xy, and look what happened. We subtracted 6 from the x and ended up with 7. So what did we start off with? And now if that's tricky for you, you can write an equation. You can say, what number, when you subtract 6 from it, would give you 7? And if you solve that, you get 13. Same thing here. Original y value gets multiplied by 3/4 and gets you 18. So now 3/4 times what would make 18? Now to solve that, you multiply both sides by the reciprocal, 4/3. 3 goes into 18 6 times. 6 times 4 is 24. So for this one, it turns out the answer is the x value is 13 and the y value was 24. So that's our answer. That was our original point P. Okay? So there you go. There's 2 more here. You can figure out these 2 below it in the exact same way we just figured out that. You can set up an equation if you want, or you can kind of just reason through it. Like we could have reasoned out that, okay, what number minus 6 makes 7? Well, 13. So. Okay, moving on. The next page, we are trying to figure out what is the algebraic rule that describes each transformation. So this time we're being given that the point x mapped for, let me reiterate here. So this is saying there's some triangle out there named XYZ. So to picture maybe on a coordinate plane XYZ, and he mapped over to another location. Now he's somewhere else, and he's x prime, y prime, z prime. Those little dashes, we call them primes. So all this is saying, though, is what's the algebraic rule that would send 5, 3 to 6, 1, would send 7, 11 to 8, 9, and negative 6, 2 to negative 5, 0. So let's see if we can figure it out. What's happening here? Maybe let's first focus on the x values. 5 went to 6, so that's 1 bigger. 7 went to 8, that's 1 bigger. And negative 6 went to negative 5, that's again 1 bigger. So that's pretty good evidence that our xy is what's happening to the x value? Well, we're adding 1 to it. How about the y value? 3 went to 1, 11 went to 9, and 2 went to 0. In all 3 times, the y value had 2 subtracted from it. So this is the answer to the question. This is the algebraic rule that does this transformation. Okay. Let's do another one. So let's jump down and do a more challenging one, because I think B and C are pretty straightforward. Let's do D. D's a little bit complicated. So 6, 1 went to 1, negative 6. Negative 2, 7 went to 7, 2. 4, negative 3 went to negative 3, negative 4. So we might be thinking, wait a second. That means that there's something going on there with the swapping, right? So we started off with xy. Like in this first one, there was a swap, but what happened? This x value is now a y value, and it's opposite. So that tells me that this x becomes opposite of x over here, and then the y value just goes directly over, so unchanged. So this one usually confuses people. So I mean, don't feel bad if you're finding it a little confusing at first. You might have to think about this one for a while before it really kind of clicks in your mind. But this transformation is swapping the x and the y values and then turning that original x value opposite to what it used to be. So Finish the rest of this page. The rest of the questions are pretty similar. Some are pretty straightforward like this, where you're just adding or maybe you're multiplying the x values. And so a couple of them are a little bit more confusing. They involve swapping the values. So just try your best on those. Next, we're going to start looking at what happens on these transformations. What happens to, like, say, a segment. Say you have a segment on a coordinate plane, and you do a transformation. What happens to, like, its length, maybe its orientation, and then we're going to use this these words here, rigid or non-rigid. So rigid would be like, here's my pen. If we take this pen and just move it over, that's rigid. Like here's its length, right? If I shift it up, did we change its length? No, it's the same size. But here's a rubber band on my desk. Some transformations, you'll have something and it'll go like this. It'll stretch it out in some way, or it'll deform it in a way that we'd call non-rigid. So rigid and non-rigid kind of have the meanings that you think they do, like in real life. Like, solid steel, that's rigid. Rubber, non-rigid. So let's just get into it here and try to look at the difference. So, all right. We're always starting with the segment -1, 1, and as our A, and then 1, 2 as our B. So -1, 1 is over here, and then 1, 2 is right there. So there's my segment A, B. So the first question, it says subtract 3 from the x values. Okay. So if we subtract 3 from this x value, I would get -4. So my A prime would be -4. Notice the y value doesn't get changed. So this transformation says subtract 3 from the x value of your point and don't do anything to the y value. So I used to have the point -1, 1. I subtracted 3 from the x value, and now I have -4, 1. Likewise, I'm going to do the same thing to b. I'm going to subtract 3 from the x value, -2, and then leave the y value the same. Now let's see what happens. What happens to this segment when we do that? You might already know the answer. You might in your head go, wait, wouldn't subtracting 3 from the x values just move it left? If you thought that, then kudos, that's correct. So if I graph these points, -4, 1's right there, so that's where my A prime was. And then B, -2, 2. B prime. Now, so that's what happened. The whole thing shifted left 3 units. So it says we've defined the length of the new segment. Well, let's do that. Hopefully you've had enough practice with your Pythagorean theorem by now that we can do these a little bit quicker. So this little right triangle I formed to find the area is a 1/2. And so when I do Pythagorean theorem, 1 squared plus 2 squared equals distance squared, I'm going to get 5 here. And so the distance is √5. Which I hope you're thinking, well, yeah, isn't that exactly what we would have gotten if we had just found the length of the original segment? And yeah, so this one is rigid. This is a rigid transformation. So all it did was it slid it over to the left. Okay, it did not change the size. I'll leave B for you to figure out. I'll give you a big hint though. What do you think happens when you subtract 4 from the y values? Subtracting 4 from the y's is going to send it down. So you're going to have your segment, your AB, and it's going to just shift down. So let's do one that's a little bit, maybe, let's do 1 or 2 more of these here. All right, what does this one do? This one says take your x value, so take the opposite of your x value and then keep your y value unchanged. So what's that going to do? Well, again, here's my A, B, my original point, my original segment, sorry. What happens when we take the x value and make it the opposite of what it used to be. Well, now this negative 1, 1 is now positive 1, 1. So A prime would be positive 1, 1. And then B prime is going to be, instead of being 1, 2, it's going to be negative 1, 2. So if you think about it, what happened was the segment got flipped around the y-axis, and you can see if I were to calculate the length, the distance is just going to be root 5 again. Okay, so this was again a rigid transformation. So that one, so if you take a segment and you flip it, or we're going to eventually start calling those reflections. So if you reflect it, it's still rigid. Okay. So you'll have here's D. That's another one. Let's do D together, because this one could be a little confusing. Just to make sure we're all on board here. So what happens here? So you swap the x and the y values, but also that original y value is made opposite when it turns into your new x value. So let's actually draw so for point A, it used to be negative 1, 1. And so swap them, but also make that original y value opposite. So it would now be negative 1, negative 1. How about B? B used to be at 1, 2, and now it's going to be at negative 2, 1. So let's look at what happens there. Again, our original drawing, original one looks like this. There's A, B. But now A is at negative 1, negative 1, so he's down here. And B prime is at negative 2, positive 1. Right there. Sorry if that labeling is confusing. So A is that original point, and B prime is this new point. So that one's a little weird, right? Because it's like, now it's kind of got turned, and that's actually exactly what happened. We took it, we'll get into this later in the class, but it got rotated, but it was rotated around the origin, 0, 0. So the center of rotation. Imagine a wheel spinning. Oh, there's the light again. Imagine a wheel spinning. A wheel spins around its center, and the points on the outside of the wheel rotate around that. So that's kind of what's happening here. You get the segment, and it rotates around that center. So, but don't worry about that too much for now. What you got to realize, though, is, hey, look, if we were to find this length, isn't this the same calculation we just did already? It's a 2 by 1 triangle. So the distance, again, is, or the length of the segment is still root 5. Again, this is rigid. So now maybe you're thinking, wait a second, are they all rigid? Is this like some sort of trick, or what are you getting at here? Are you just going to say they're all rigid transformations? No, they're not all rigid transformations. We'll do this one now. So you got, again, your original pair of points. This one says multiply the x values by 2. So my A prime is going to be negative 2, 1, and my B prime is going to be 2, 2. When I draw that, look what happened. So my B prime is way out here, and my A prime is way over on the left there. Well, how long is he now? How far apart are these points? Well, it's a 4 by 1 triangle. So 4 squared plus 1 squared equals distance squared. You end up with root 17. So, I mean, that's a little confusing. You go, wait a second, I used to be root 5, now I'm root 17. That's kind of strange, but That's what it is. So this one's a little weird. When you doubled the x values, it stretched it horizontally. So I'd like you to think about that. Think about, okay, why is that happening? Why does doubling the x values stretch it horizontally? It might make sense to you right away. It might not. You might have to think about it for a while before it kind of makes sense in your mind. Okay, now I'd like you to now we've pretty much covered all the basics. Okay, so you hopefully now know how to apply these transformations in general. I think I'll make a follow-up video. I got to go now. My next class is coming in, but I'll make a follow-up video kind of going over like a couple more examples from doing it with shapes. So anyway, stop the video for now.